right, we've got a dart game. John has 40% chance of getting bullseye. Pete has 30% chance of getting bullseye. And John throwing and getting a bullseye doesn't change Pete's chance of getting a bullseye. So the probability that they both make bullseye, that's probability that Pete and John happen. So 40% times 30% is a 12% chance of them both getting bullseyes. Independent events we also have if we draw marbles or something else from a bag and we put it back. So if we put it back, we're not changing future outcomes. So putting it back also causes independence. So 6 white, 9 black, we're choosing one, put it back, choose a second. Probability of getting white, white, well, that's going to be 6 out of 15 times 6 out of 15. That's the same as 2 out of 5 squared, so a 4 in 25 chance. Continuing on, we have to write 2 exams. Probability that you pass either is 3/5. If our performance is independent, probability that we pass both, that's going to be 3/5 squared, or 9/25. Pass only one, that would mean pass, fail, or fail, pass. Well, if my probability of passing is 3/5, probability of failing is 2/5. So I would have 3/5 times 2/5 plus 2/5 times 3/5. So 6 out of 25 times 2, 12 out of 25 chance. Passing at least one means that we did not fail both. So remember when we looked at permutations and combinations, I talked about how at least implied that subtraction is the easiest way to solve. So I'm going to take 100% probability and subtract the probability that I fail both. So 1 minus fail, fail, that's going to be 2 out of 5 squared. That's 4 out of 25. So 21 out of 25 chance that I do not fail both. Notice I also could have just added these two because this is passing both and passing only one. So passing at least one means I do one of those two things, so I could have added those as well.